This is the multiple choice section, or what I would call the atoms basic section of the test. And our first question deals with aluminum. Actually, the first 4 questions deal with aluminum. So if we were to write the symbol for aluminum, it would be Al. Aluminum has 13 protons. You'd find that by looking at a periodic table. And the mass is 27. Remember that the mass is the number of protons and neutrons all together. The atomic number is just the number of protons. So, the first question says, what is the total number of protons and neutrons in aluminum? So that would be the 27, because that's the 27 protons and neutrons. The number of protons by themselves would just be 13. The number of electrons. Electrons equal the protons if no charge. So if there's no charge on the atom, then the electrons and the protons are the same. Since there's nothing here that indicates a charge, like if there was, you might say +3 up here, that would tell us that the charge is +3. But this doesn't indicate that. So we're going to take a little +3 out, because there's no evidence that there's a +3. It doesn't say anything about a +3. All right. So since there is no charge, then we've got to assume that the electrons and the protons are the same. So the answer would be 13. So the protons plus the neutrons equal the mass. If we know that there are 13 protons, and we know that the mass is 27, we really have 13 plus n equals 27. So how do you solve for n in a math class? You'd subtract 13 from both sides. 13 minus 13 is 0, so n is equal to 27 minus 13, which is 14. Number 5, the smallest unique unit of an element. Now remember, elements are made of one kind of atom. So the simplest piece of an element is its atom. Protons are simpler, but protons are not unique. A proton from aluminum is the same as a proton from calcium, or the same as a proton from chlorine. In other words, a proton is a proton. Same is true for electrons, and same is true for neutrons. So all of these are not unique to an atom or to an element. In other words, they are the same. They're generic. No matter what atom a proton from any atom is still just a proton. Now, in terms of the size of these particles, electrons are way small, and neutrons and protons are like 2,000 times bigger than electrons. So electrons are by far the lightest. Okay, now the particle that gives a nucleus a charge. We had a little grid that we did in class. It was protons, neutrons, electrons, then mass, and charge. Oops, got off the screen there. So the mass on protons was 1, and neutrons was 1, electrons was 0. But the charge on protons is positive, and neutrons were 0, and electrons are negative. Since protons and neutrons are in the nucleus, then we know that the protons are what gives the nucleus a charge, because neutrons don't have a charge. This question, number 7, says electrons are negatively charged and have the most mass. You know, they are negative, but they don't have the most. They have the least mass. So this statement is false. This statement, number 8, the charge of the neutrons, what does it say up here? They are always 0. Okay, so we're going to come down here. The charge of the neutron is always 0. Well, there's no 0, but the word neutral is there, which means 0. Okay, number 9, isotopes. There are 2 words that we talked about in terms of being variations of atoms. One of them, isotope, has to do with varying neutrons. So in other words, different numbers of neutrons. So isotopes vary neutrons. The other is ions. And ions vary electrons. Okay, if you vary the neutrons, oops, didn't want to do that. Let's undo that. If you vary the neutrons, mass changes. If you vary the electrons, charge changes. All right, so in this case, it's an isotope. So what are we varying? We're varying neutrons. So the answer has to be that one, and that does change the mass. Okay, the electron cloud. Electrons are negative, so you know the electron cloud is either negative, it's either A or D. It's got to be negative, it's not positive. So A or D are the answer. We've said a lot of times that the electron cloud is mostly empty. I gave an analogy with Busch Stadium. If this atom was as big as Busch Stadium, then all the mass is in the tennis ball at second base, and the rest of the atom is just empty. So we would say that it's negatively charged. If it's empty, it has a very low density. Okay, so that brings us to number 11. The mass of the atom's in a pinpoint in the center. That's true. It's called the nucleus. All the protons and neutrons are there. Since protons plus neutrons equal mass, 84, the mass number, includes all the protons and neutrons. That was B. And we just a few minutes ago said that if neutrons vary, mass varies. So different isotopes have different atomic mass. It's true. So that brings us to number 14. What is then the defining thing about an element? All atoms are the same element. What's the same for all of them? Well, it is their number of protons. Well, number of protons is not here. What means number of protons, though, is atomic number. Number 15. So once again on 14, atomic number is defined as number of protons, and number of protons identify the atom. That's where they get their unique identity, by how many protons. Number 26, or 15, aluminum 26 has blank neutrons. Well, we know that protons plus neutrons equals mass. For aluminum, protons are 13. We're trying to figure out the neutrons, so we'll put a question mark, and that equals the mass, and it tells us that 26 is a mass number. Subtract 13 from both sides, and what do you get? So that would be the number of neutrons. Note that 27 is not the mass number on, or excuse me, 26 is not the mass number on the periodic table. 27 is on the table. So these are isotopes. They have different numbers of neutrons, but the mass, so the mass changes. They have different number of neutrons, so the mass changes. But the protons are the same for both. They're both 13, they're aluminum. Okay, and the last thing, neon lights give off light when the electrons do what? Well, they move away when they get excited. When they come by electricity, when they come back down, they give off light. So when the electron falls back, it gives off light. So that would be the end of this section of the test, and I will upload it momentarily to YouTube. Thanks.